Hey, hope everybody's doing well. This is, I'm working on a Snell PS10 powered subwoofer. It belongs to a buddy of mine. And he turned it on and the power light wouldn't come on and stuff. And so I went over there, we checked, make sure, you know, the plug was good, and then we checked the fuse was good. And so I told him, I said, you know, I'm gonna have to dig into it. And I know it's hard to see, but just feeling this cap right here, man, it's got a major league bulge in here. And so I'm pretty sure that's one of the problems. And I'm going to check the caps here. And there's some other caps right here that I'm going to check. But basically this is a class, probably a class A/B type amplifier. How do I know that? Because of this huge transformer. This thing weighs probably about 30 pounds, just this thing. And then with this, I mean, this thing's got to weigh probably about 35, 40 pounds just right here. So anyway, I've loosened all the screws and stuff, and now I just got to get this board out of the way, or rather loose. And so I got to be real careful not to ruin any of the transistors over here. So that's kind of where I'm at with this amp. Once I get this out, then I'll do some more video on it and stuff. So, okay, just want to let y'all know that's where I'm at right now on this amp. Checking these huge caps, and like I said, I'm running my finger over that. It should be flat. Like this one's flat, but still, even if they're flat and don't have any bulge, they still could be bad. And this is an old, oh my God, this amp has to be, I wonder if there's any date on here. Sometimes they put a date. No, I would have to say this amp is probably at least 10 years old, 10 to 12 years old. So, all right, be back. So hey, hope everybody's doing well. This is, I'm back with the sub amp that I'm repairing, and got my little tester out here, capacitor tester, LCR meter. Yeah, this is a cheap Chinesium. Seems to work well. I got another somewhat of a little better one upstairs. It's a much bigger unit, but this one seems to do a decent job. Right now I'm calibrating the leads, so it's open. Let me zoom out just a hair. So it passed the open, meaning you open. Now I'm going to click on the cal and short. So they want you to short them out, short the leads out. Press the button. It takes about 30 seconds. And I guess what it's doing is it's taking out any resistance in the leads and stuff. So and kind of wait. Okay. Now at this point, so you press. Now we can go back. Let me go ahead and. These are the two original capacitors that came out. They're 10,000 at 80 they're 10,000 microfarads at 80 volts. That's what they are. Here, let me turn them over this way. Excuse me. This negative here, or this negative here, you can see that one better, shows you where the negative is down here. Now these are kind of weird because they're multi-poled. So they have 3 poles here on the positive side. And according to what I was reading on AI, which, you know, got to take that with a grain of salt, but I mean, to get the real information from, say, the caps, I would have to go to this company SUSCON, and then read their data on why there's a 3 poles. But according to AI, it says that it's to distribute the capacitance load better and stuff like that. But they're all connected to the same place. Okay, obviously this is the negative side, and then these would be the positive side. So anyway, this guy, it's hard. I've already taken this off, but it's definitely bulged. Okay, and it's a maraca. My buddy Cliff, who's a drummer, I told him, man, you can use that, as some percussion there on your drum set. So let's test this one out first, okay? All right, so I hope you all can see the screen there. Let's see. Kind of. Let's try that. Now this is battery powered right now. It's a 9-volt. I do have the power where you connect it into the power, and so sometimes it's better connected into the power, because especially if you're doing a lot of measurements. So I'm putting the negative on there and putting the positive on here. Now so let's see, I want to check ESR. Let me see if I can get this to work, because I was having some issues the other day. Actually, right now I'm having some issues because it's just not wanting to do what I want it to do. Let's see, and then go here. All right, let's see what will happen. Yeah, it doesn't seem to be reading anything. That's kind of bizarro. All right, well, let's try this one, the other one that I took out. Get up there. Let's see what will happen. Yeah, this is a little bizarre, because last time I was doing this, we were at least getting some readings. And again, could be that I need to connect my external power supply to this guy, but let me see what will happen here if I just go. Oh, I know why. Let me go back. Let's change the frequency to 110, because that's basically what it runs off of. 120. There we go. Yeah. Okay. So these caps are in a power supply that is the frequency here in the United States is 60 hertz. So obviously the frequency, if the frequency is a lot higher, then you're probably not going to get any readings out of these. Are there caps that would work at much higher frequency? Yes, there are. Okay, so right now I'm getting 9.27 millifarads. Okay, so it'd be 0.00927, or if we move the decimal point to the right 3 places, it'd be 9,270 microfarads, and that's pretty darn close. I mean, that's within 10% of, if I'm not mistaken. Let me get my calculator here on my phone, and let's figure out what plus or minus 20% is. So let's just do it right that way. I'm not. So 10,000 times 0.2. So 8,000 would be the lowest range, and 12,000 would be that. So the capacitance on that guy is within range. Okay. And that's this one from the amp that doesn't have any bulge on it. Okay. Now we can try the other. I can try this other lead. I don't know, just for S&Gs. Let's see what will happen. Yeah, I'm getting some weird reading there. I'm getting like 324 nanofarads. And then this top number ESR, equivalent series resistance, you typically want that to be as low as possible. 0 would be great. 1 is okay. It's 22 mega ohms. Let's try the other one. I just moved it to the other. And again, I'm getting, 58.79 nanofarads. And then if I go to the middle one, yeah, so I'm getting 0 for ESR, and I'm getting 9,280 microfarads. So probably still good, but you know, they were, I think my buddy, we managed to find these online, and my buddy ordered, he had to order 4 of them for like 45 bucks or something like that. All right, so let's try this one. Now this one does have the bulge on it. So let's go ahead and put the negative on here first, and then put the positive on there, and let's see what will happen. Let's see what we get. I want to say the last time I checked this one checked decent also. Now it's possible that there's another issue. You know, maybe the transformer went out. I don't know on this amp, but I'll end up figuring it out. But I guarantee you, that's not normal. And I would not want to have that back in the amp. Okay, let me go to this other place over here. And yeah, this is reading 17.147 nanofarads. 87.4 mega ohms of resistance. Yeah. Okay. And then here I'm reading 86 point on this side over here. I'm just going from the middle. Okay, from the middle one, and I'm getting 9,560 microfarads, which is, like I said, it's within the range. But then when I move it over to either this one over here or this one over here, I'm getting some weird readings. And again, the way it was explained on AI, it's that, I mean, all these are connected to where this one's connected to on the board. That's connected to the same place. They just have different holes, and you have to solder them in there. So I'm not going to put that one in there. So, all right, these are some new ones. These are the new ones. 10,000. It's a different company. 10,000 microfarads at 80 volts. And so, let's see. So there's the negative. And there's the positive. And so these are reading, let's let it set down there. Yeah, these are reading 8.33 nanofarads. And so we move the decimal point to the right 3 places because I'm sorry, not nanofarads. Millifarads. Milli is 10 to the negative 3. And so to make it into micro, we move the decimal point again that way. So it's 8,330 microfarads. So it's within the plus or minus 20. Okay. Now I'm curious. I'm going to move it over here. See what will happen here. Yeah, it's reading almost about the same as the other ones, these guys over here. Oops, sorry. 20.5 nanofarads at 8,000 ohms and stuff. And then on the other side, I've just moved over to the other side. I guess what I could try and do is just, could I try and see if I can get both of them? Let's see what will happen here. Yeah, it's still reading the same as if I'm putting, all I'm doing is I'm shorting those two out there, the center one and this one, and I'm reading the same thing, 8,330 microfarads. All right, so that one's, I'm assuming it's decent. Let's try this one. See what we get. Yeah, we're getting 8,590 microfarads. And then let's see what it'll read from here to there. It's going to be in the nanofarads, I guess, I'm assuming. Yep. And then over here, yeah. So anyway, I mean, is it possible that these two guys are still good and there's something else wrong with the amp? Sure. And you know, I'm gonna try and figure that out. But definitely, that's not good. What I may end up doing is in a later video, I'm gonna go ahead and open this one up to see how it is inside, and basically do a little bit more investigation as to how these things are made internally and stuff. Now, one word of advice. If the voltage on this is more than, say, 120 volts, you know, like 220, 350, you better be real careful when you're taking one of these guys out. I was working on a Canon flash that a buddy of mine, it stopped working, and he says, "Here, man, you know, knock your stuff out, see if it'll, you know, see if you can get it to work." And I had it here, as a matter of fact, and I was taking it, and it has basically a flash has a 9-volt. Actually, has that one had 4 AA's. And then they have a way to step up the voltage to 400 something, because they got to charge a capacitor. Because when you press, you know, the shutter on the camera, the release, it's going to shoot off. Well, it's got to have that energy to get to the flash, and it comes from the capacitor. And man, I tell you what, that thing bit me. It definitely woke me up. And it was a 450 volt DC microfarad, and I can't remember what the capacitance was on it. I think it was like 15,000 or 18,000 microfarad. So I mean, it can store a lot of energy. So you got to be real careful with those. And also working on Class D amplifiers, I'm not trained on those. They are a different animal. I've been following this guy online. I can't remember his name, and he's kind of showing how to repair them. Those definitely in the power supply also use very high voltage caps and stuff, because they have a switch mode power supply in them. And so just let me see if I can move this over. So just to give you an idea, that amp right there that you're looking at, that's not a switch mode power supply. This, and the way I know is that because of this huge transformer. The layout on this amp is probably a Class A, B style amplifier. I'm not going to go into the whole thing about that, but your audiophiles, if you will, the guys who have albums and records and all that, their amplifier, their topology of amplifier or preferred amplifier is a Class A amplification. Most of your tube amplifiers, you know, like Macintosh and stuff like that, those, I'm sure there's some other companies I can't think of. I used to work in the industry. They're Class A type amplifiers, and they sound beautiful. When you start getting into Class AB, the only difference is that the amplifier is not on all the time, and so you have less heat at the heat sinks on the Class AB. Class A, there's a constant current flowing through the amp, through the speakers, but it's very low, you know, probably less than half a watt, or I'm sorry, half a volt. Yeah, a lot less than that. Talking the millivolts. But with time, if you just leave the amp on, it does heat up. Now, Class D, it's different, man. Class D, you basically have you have a carrier frequency, right? So they have to generate a carrier frequency, and then your audio comes in on that carrier frequency. They add them together in a special circuit, and then they take that and they amplify that, and then they send it out from the amplifier section, which is a Class D amplifier section, and then before it goes to the speakers, they take out the carrier frequency. Okay, and that's kind of how television and radio transmit. Let me turn that off. How you get radio frequencies and stuff from your typical television, your off-air antenna, although it's digital, but they're doing the same thing. They have a carrier frequency. If you ever wonder, like, how does your AM radio or FM radio work? Well, that station, the number in the station, that is the carrier frequency. In this area we have, like, back in the day it was KB 104, KBFM 104, and I mainly listen to an AM station called 710. Well, 710, it's 710 megahertz. That's the frequency that they add the audio to, and then they amplify it, send it to the antennas, and it goes out. I think it's a 100,000 watt antenna, and then your radio, when you tune into the radio, they amplitude modulate, and that's the modulation of that 710 megahertz frequency, and they add the audio to it, and then your radio, when you turn into 710, what that does is it decouples or gets rid of, goes through a demodulation circuit, and it gets rid of the 710, and then all you have is audio, and then the audio goes to your preamplifier, and then your amplifier, and then to your speakers, and that's how you hear it. FM works kind of the same way, except that they're modulating the frequency. That's why it's called FM, frequency modulation, and AM is called amplitude modulation. Anyway, you can type it up, ask AI to look at it for you, but just be aware AI sometimes, I don't trust it 100%. And I'm sure on YouTube you can find some guys that explain that just a whole lot better. Your cell phones pretty much work the same way, except on your cell phone you not only have audio, you have video, and then video and the audio, and then you have texting, and you have internet. So you have a lot of information is going out to that. So anyway, okay. So my next thing to do here is, I've already kind of loosened all this up. I'm going to go grab my tools. I'm going to go ahead and pull this out, solder these guys in, and then attempt to turn it on and see what happens. And I'll record all that while I'm doing that. So, all right, be back in a while.